Hello everybody. So we're starting lesson 6.7 as we're going through trigonometry. Today the main focus is solving right triangles. So kind of a lot of notes here, but once we get going, I don't know, you may not need to flip up here for anything really, or maybe just once in a while. So let's talk about this. So we've previously covered all 6 trigonometric ratios. When you solve right triangles, you usually use the main 3, or SOHCAHTOA, so sine, cosine, and tangent, and I rewrote those out here in a little box just for reference. Also when solving triangles, the Pythagorean theorem may be useful. So that's your standard a squared plus b squared equals c squared when you apply it to a triangle, right triangle. We will be using inverse trig functions to solve for missing angles. Inverse trig functions are sine inverse, cosine inverse, tangent inverse, that little -1 up there representing the word inverse. We've not done that in this class. You should have done that probably in geometry, but been a couple of years. So yeah, just kind of a review thing potentially. Also, we may be using the very standard fact in geometry that the sum of the interior angles of a triangle is, and I'll pause there, say something to your iPad right now. You got it? All right, if you said 180 degrees, you are officially a math nerd. No, it just means you remembered it from geometry. So in other words, if you add up angle A plus angle B plus angle C in any triangle, you always will get 180 degrees. Now for a right triangle, since one angle is always going to be 90, then we could say the sum of the two non-right angles would have to be 90 degrees, because 90 out of 180 leaves 90 degrees left for the other two angles to add up to. So if we're just dealing with angle A and B, the measure of angle A plus the measure of angle B is 90 degrees. So that's just a good fact or a little piece of knowledge to have. Now that stuff we probably won't use until we get down to the last 4 problems, my last 2 examples. But yeah, that will come into play. So apologies if this is too much of a review. This is probably the sort of assignment you could have done in a geometry class once you've covered SOHCAHTOA, the whole sine, cosine, tangent thing. But again, because it's been some years potentially since you've done that, and it's kind of a standard thing to know in trig, and we're really taking trig and we're hopefully going to be expanding into things you've never seen before, it's worth reviewing. So we are going to find the measure of the indicated side. So in every problem we're doing here, we're trying to find the length of a side. Round to the nearest tenth, we will be using the calculator. So I'm going to go ahead, I'm going to get rid of what I highlighted there because you don't need to see that. I'm going to pull up Desmos so I've got it convenient to use. And it looks like everything in this worksheet will be measured in degrees. Everything has degrees. There's no radian anything. So I'm going to hit the gear real quick and make sure I've set my calculator to work in degrees. Make sure you do that as well. Okay, so as usual, I'll do the evens, you do the odds, starting with number 2. We are asked to find x. Now in this diagram, the x is the hypotenuse. So to solve for x, we need one of these formulas, and we need one that has hypotenuse in it. So it's got to be either this one or that one, because they both have hypotenuse. But which one do we use? So part of this exercise is you selecting the appropriate formula to use. And you know, these are the trig ratios or whatever you want to call them, trig functions, but they really are formulas. This theta is a variable. Opposite and hypotenuse, I know they're abbreviations for words, but they really represent variables as well. And we got an equal sign here, so that is a formula. So how do we select which formula to use? Well, that depends on the other information that's given. So our theta is up here. 12.3 touches the angle, so that means that this is the adjacent side. So we're given an adjacent, and we're trying to find a hypotenuse. The formula that has adjacent and hypotenuse is cosine. So to do problem number 2, we need to use cosine. Cosine of theta equals adjacent over hypotenuse. So the first step in any one of these problems is selecting the appropriate formula. As with any geometry problem or any math problem where you use formulas, next you want to plug numbers in for the variables. So theta becomes 69 degrees, that's right here. Adjacent is 12.3, and I want to create a little bit of space here. Also, yeah, my handwriting is good as usual, so I'm going to correct that. Okay, so theta was 69 degrees, adjacent 12.3 over hypotenuse. Hypotenuse we don't know, that's the x we're trying to solve for. And so that's the equation we need to solve. How can I solve for a variable when it's in the bottom of a fraction? Well, the best bet is to go ahead and multiply that on both sides. That cancels this out. So I get x times cosine of 69 degrees equals 12.3. Now to solve for x, divide both sides by cosine of 69 degrees. Okay, for some reason today I cannot write the number 9. That cancels out. I get x equals, well, this. What's that? Well, let me use a calculator and find out. 12.3 divided by function cosine 69. And this works out to be approximately, 34.3. So if I've done my math correctly, that will be the right answer. Let me scroll down to number 2 and check, and there it is. So, do you recall doing work like this before? I hope so. I hope it's not so familiar to you that it's tedious, like, oh, why do I have to do this again? And if it is that scenario, I'm sorry. But we really want to make sure we have this skill nailed down. So, all right, let's move on. Number 4. So our variable is here, our theta is up there. The other side that's given in this context would be the opposite, the side we're looking for, that's touching theta, so that's the adjacent. So I need a formula that has opposite and adjacent in it. If you have them memorized, great. If not, you just scroll up and look, and it's right there. Tangent has opposite and adjacent in it. So the formula for tangent, I'll just copy it down. You might not have to do this step, it's up to you. Then you plug everything in. So our theta is 29 degrees. And you know what, I'm not going to write degrees in. It just gets too tedious to write that over and over. So tangent of 29 equals opposite, which is 3, over adjacent, which is x. And once again, we've got a problem with a variable in the denominator. So to solve that, I'll want to multiply both sides by x to get it out of the denominator. X tan 29 equals 3. Then divide both sides by tan 29. That cancels out. And then I use my calculator. 3 divided by tangent of 29. And I get 85.9 as my answer. And once again, that should be approximately because I've rounded this off. Let's check number 4. And that's not even close. What the hey? Oh, I'm dumb. What a maroon. No? Alright, kids, what did I do wrong? How did I get 89.5? That's not even possibly realistic. I mean, if this side is only 3, the other side's not going to be 89. What the heck did I do? Opposite over adjacent, 3 over x, 29. Oh, tangent of 2. I forgot to hit the 9. Jeez. That's a dumb mistake to make. All right, so I got 5.4. That sounds better. And this is why you check your work, 5.4. Yeah, I just did tangent of 2 on the calculator instead of tangent of 29. All right, so anyway, hopefully with those examples, you can move into 1 and 3 and do those yourself. Let me now go on to number 6. Now, 6 is exactly, oh, shucks. I put these in the wrong order. No, I didn't. What? Kids, not kids. Students, I am sorry. I'm just messing with my own brain right now. Getting confused, worried that I made the worksheet wrong. I don't know. I have no excuse. All right. Anyway, let's move on. Number 6. Number 6 is exactly the same as 2 and 4. It's just the diagram isn't provided. So you need a diagram. So draw yourself a right triangle and then label it ABC accordingly. So let's go A, B, C. A and B don't matter. You do have to make the right angle C. This is little a, this is little b, this is little c. And then plug in what we have here. So angle A is 43 degrees. That's going to be our theta. Side C is 10. And we're asked to find side A. So in the context of this diagram, let's see. The number or the variable we're searching for is the opposite. And what's given is the hypotenuse. And of course, 43 is theta. So we're looking for a formula with opposite and hypotenuse in it. And that is sine, opposite hypotenuse. So the formula I need is sine of theta equals opposite over hypotenuse. So plug in the numbers. Sine of 43 equals A. And if you wanted to, you could use X like we did up here. It doesn't really matter. A over 10, right? Hypotenuse was 10. Got plugged in for hypotenuse. Yep. Okay, this time the variable is in the numerator. So to solve this problem, all I have to do is multiply both sides by 10, cancel that out. And so what I get is, well, whatever this is equals A. So A equals, go to the calculator, 10 times sine of 43. And I get 6.8, looks like. Check number 6, 6.8. There we go. Okay, so there's 3 problems, all the same, finding missing sides. I did where one was cosine, one was tangent, one was sine, so a little bit of everything. 2 problems had the variable in the denominator, number 2 and number 4. Number 6 had a variable in the numerator, so you've got plenty of examples to work from. Hopefully you can do 1, 3, and 5 without any trouble. Let's go ahead and move into the next set. So the directions here are find the measure of each angle indicated, round to the nearest tenth. So now the unknown is an angle instead of the unknown being a side. We still have a lot of the same principles. You got to select one of the 3 formulas. In this problem, we've got the opposite that's given and the adjacent. So based on what's given, opposite and adjacent, I know that I need to use the tangent formula. That's the one with opposite and adjacent in it. So the formula is tangent of theta equals opposite over adjacent. Plug everything in, which in this case is just plugging in 9.5 over 8. And we need to solve this. So how do you solve that? Well, first of all, 9.5 over 8, you can use a calculator to work that out. I'm not going to do it yet. What we really want to focus on is isolating a variable. So let's talk about algebra for a second. If we had theta, you remember theta is a variable. It could be a x, could be a y, anything. Theta plus 5 equals 8. We would isolate the theta by subtracting 5, right? You do the opposite of plus, which is minus. If we had an equation that was like 6 times theta equals 42, you would isolate theta by dividing by 6. Opposite of times is divide. You do the opposite to cancel it out. Well, here we want to cancel out a tangent. Now, I know that tangent is written right next to theta, and it kind of looks like times, so you might be tempted to think, oh, just divide by tangent. No, tangent's not a number. You can't divide by it. Tangent is more of an operation. So it's sort of more like a logarithm, for example. Remember how to cancel out a logarithm? You drop a base. Oops, didn't mean to erase that. So why did you drop a base with a logarithm? Well, because bases and logarithms are opposites of each other. Just like plus and minus are opposites, and times and divide are opposites. So we need an opposite of tangent. Well, that takes us back to what I was talking about a few minutes ago, the inverse operations. Tangent has an inverse, and surprise, surprise, it's called inverse tangent. So to solve this equation, what I'm going to do is I'm going to move this over a little bit. So I've got space, and I am simply going to write inverse tangent on both sides. Inverse tangent on this side cancels out tangent and isolates the variable. That's what we want. Inverse tangent on the other side just happens to be something you need a calculator for. So let me go to my calculator, hit the function button, and right almost dead center, there's the inverse tangent. Inside those parentheses, I'm going to type 9.5, not 95, come on, 9.5, divided by 8. And there, just like magic, I have my answer. 49.9 degrees would be the size of that angle. Again, I've rounded off, so technically I should use the wavy equal sign. Let me check number 8 to make sure. 49.9 degrees. All right. If there's anything confusing about that, if I did a bad job explaining it, we'll do another one. Hopefully this will be a little more clear. Things will get better as we go. Or maybe you just totally remember doing this before. It's clear already. Anyway, number 10. What's given? Well, we've got the opposite, and we've got the hypotenuse. Hypotenuse, remember, is always across from the right angle. Opposite and hypotenuse is part of the sine formula. Sine equals opposite over hypotenuse. So to solve for theta in this problem, I need sine of theta equals 3.5, which is the opposite, over 7, which is the hypotenuse. How do I solve for sine? Well, I do the inverse sine of both sides. So inverse sine here, inverse sine there, cancels out. Theta equals, and then grab a calculator. So function, inverse sine is right at the top middle. 3.5 over 7 is 30 degrees. And that's exactly 30, so we don't have to round off at all. Number 10, 30 degrees. Number 11 is the same type of question, but no diagram provided. So, yeah, good enough. A, B, C, little a, little b, little c. Find measure of angle A, so that's our theta. Little a equals 12, little c equals 16. Well, it looks like we have another sine problem here. This is the opposite, and this is the hypotenuse. I think when I made this worksheet, I wanted to give you one sine, one tangent, one cosine, and it looks like I screwed up. This one is another sine problem. Oh well. It's not a big deal. So sine of theta equals opposite over hypotenuse. That's the formula. Not that you need to do that step, but you can always jot it down if it helps. So sine of theta equals opposite, which is 12, over hypotenuse, which is 16. And for once, I remembered to leave a space. What's the space for? That's so you can write inverse sine on both sides. Theta equals the inverse sine of 12 over 16. So let me go to functions, inverse sine, 12 over 16. And that rounds off to approximately 48.6 degrees. Check number 12. Where is it? There we are. And it looks good. Okay, so first page in the worksheet, find a missing side. Second page of the worksheet, find a missing angle. The third page is to solve a triangle. Now, solving a triangle, look at it this way. Every triangle has 3 angles and 3 sides. That means there are 6 numbers associated with every triangle. Now, since they're right triangles, one of the numbers is always going to be 90. That's a given. Some other things are going to be given. That leaves the rest as variables. Solve a triangle means find the value of each remaining variable. All right, let me get rid of this. There's too much scribbling on there. What do we need? We need a little b over here, a little c over there. I'll write little a equals, in case it helps, there. To solve this triangle, we need to figure out what is capital A, what is little c, and what is little b. Cool? All right, so we decide what is going to come first. I believe that capital A is going to be the easiest thing to find. The measure of angle A is, well, okay, so this is 90 degrees, that's given. This is 38. Angle A has got to be 90 minus 38. Remember, all three angles add up to 180. Since one of them is always 90, that means the other two would have to add up to 90. So just subtract 38 from 90, and you get angle A. So what is, let's see, 90 minus 30 is 60. 90 minus 38 is 52. 52 degrees. So there's one of our answers that quick. Now what? Well, it doesn't matter which one we do next. We got to find little c and little b. Let's say for the sake of argument, I want to go with little b. Little b in this problem is the opposite, and we are given the adjacent to deal with. What formula has opposite and adjacent in it? That's tangent. Tangent of theta equals opposite over adjacent. And yes, you could scroll up and check the box to make sure if you need to. I didn't need to, I just knew it, so whatever. Okay, now fill in the numbers. Tangent of 38 equals opposite, which I'm going to use b, over adjacent, which is 10. To solve for this b, you got to multiply both sides by 10, cancel that out. B equals, what is 10 times the tangent of 38 degrees, approximately 7.8. So one answer, 52 degrees. Next answer, 7.8. Here, I could write it over here, 7.8. Now we need to find side C. To find side C, you could set up another trig ratio using adjacent and hypotenuse if you want, because C is the hypotenuse. Or you could just do the Pythagorean theorem, which is what I'm going to do. It's a little less work, I think. So remember, a squared plus b squared equals c squared, right? So 10 squared plus 7.8 squared equals c squared. 10 squared is 100. 7.8 squared, I have no idea. 7.8 squared is 60.84. So 100 plus 60.84, that's 160.84 equals c squared. Solve for c by square rooting both sides. Oops. So what is the square root of 60.84? It's going to be 12.7. So there, we found every missing measurement from the triangle. A 52-degree angle, an opposite, which is 7.8, and a hypotenuse, which is 12.7. Let's check the answers and see. 52, 7.8, 12.7. There we go. The triangle is solved. Now, do you have to write your answers up here like they did in the answer key? No, not necessarily, but I admit I do like the way that looked down there. So you could say that's my answer. By the way, make sure you're showing your work. You don't have to do every single step, but you can't just have answers here. Obviously, there is work to do. All right, number 16. So here we've got little a we need to find, capital B, and capital A. So two angles and one side we need to figure out. Let's see, got a notification? Okay. So what are we going to do? Let's find little a first. That's pretty easy. We can just do the Pythagorean theorem. A squared plus 5 squared equals 10 squared. Or a squared plus 25 equals 100. Subtract 25. A squared equals 75. Square root both sides. What's the square root of 75? I don't know. It's 8 point something. Square root of 75. 8.7. So this side is 8.7. No trig there, right? We just used geometry. Now we need to find an angle, and for this we do need to use trig. Let's say I want to find angle A first. A comes before B in the alphabet. Sure, why not? That's my theta. There. So how am I going to do this? Well, finding a missing angle is like one of these problems. We need to set up a trig formula, use inverse trig to solve it. So what am I dealing with here? Well, I'm not going to use the 8.7. Number one, it's a decimal, which is more work, well, at least it's more writing when you have a decimal. Also, potentially I got A wrong. I could have made a mistake somewhere in here, and that's the wrong answer. Do I want to use a wrong answer in calculating other parts of the problem? Not really. So I'm going to use the 5 and the 10 here. 5 is the adjacent, 10 is the hypotenuse. What formula has adjacent and hypotenuse? That's going to be cosine. Cosine of theta equals adjacent over hypotenuse. By the way, I do realize that my theta was sloppy, so I erased it and rewrote it, and I rewrote it equally sloppy. So that's me all over. Okay, there we go, theta. So cosine of theta equals, leave a space, adjacent 5 over hypotenuse 10. Do the inverse cosine of both sides to solve for theta. And here we go. So function inverse cosine 5 divided by 10 is 60. So this angle up here is 60 degrees. Now to find the other angle down here, angle B, well, that's pretty easy. The measure of angle B is just going to be 90 minus 60, which is 30 degrees. So this is 30 degrees. So my answers are 8.7, 30 degrees, 60 degrees. Let's check number 16, see if I'm right. And here we go, 8.7, 30 degrees, 60 degrees. So when you are asked to, where am I? Right here. Solve a triangle, solve each triangle, you're looking for 3 answers. You're probably going to need to use a Pythagorean theorem, a squared plus b squared equals c squared. And you're going to either need to use trig or inverse trig. It's just the way these kind of go. Okay, I am going to stop there. Please contact me if you have trouble or issues. Otherwise, good luck, and I will talk to you later.